Okay, in this lecture, I'm going to do a final example of render to texture, and we're going to do picking, and the method of picking, which I touched on briefly when we discussed interactivity, is to use a separate rendering where we render objects in a distinct color and then use that color to say what the object is. In this case, our object is going to be the rotating cube, and what we want to know is which face we've clicked on with the mouse. And so the reason we want to do render to texture is we really don't want to see the colors, the distinct colors we're going to use to render that cube so that we can select the face. So for example, let's look at the example and then we could probably understand this much better. So here's the example that's in Pick Cube under chapter 7. So here's the cube, and what I've done, this example would actually be much better if I did it with lighting and shading. If this was a cube in which all the faces had the same material properties, and I rotated it and I lit it, I still might want to know which face I'm pointing to, and that would be difficult for two reasons: that the shades change as we go across the cube, and they also will be the same for every face. So how can I distinguish among the faces? So that's why we render off screen each one in a separate color, and I want to do it off screen because if I did it on screen, you'd notice it flickering in and out between the normal rendering and this rendering in distinct colors. So the reason I did it this way, with just assigning a unique color to each vertex, which in fact doesn't really matter, and then using the default interpolation across the face across each face, is that I wanted to make the code as simple as possible, so we know how to do this almost trivially. But you could see the problem. If I want to use the mouse to select one of these faces, the color values are changing as I move the mouse across the face, and now if I start rotating it, of course, it becomes much more complex. But if I do this off-screen rendering where each face is in a distinct color, and I pick red, green, blue, cyan, magenta, yellow. Now what I can do is pick each face off-screen by the off-screen rendering and map the color that's returned by GLRead pixels into which face I'm pointing to. So let me rotate it a little bit more, a little bit down here. Okay, well, so if I now what I'm doing in this example, and we'll go through the code pretty quickly, is that I'm going to print out with the console log, again, just to make things simple, which face I'm pointing to. So in this case, I'm pointing to the face that I labeled magenta. Here I'm not pointing any face, so it's returning just background on the console log. And now let's go and rotate it, and this works while I'm rotating. Let's see, that's the green face. This is the cyan face. This is the green face, the cyan face. And obviously it's not depending on where I'm clicking on that face. It's getting the color assigned to that face. Maybe it would be clearer if I called it face 0, face 1, face 2, but I think you should get the idea. So what does the code look like to do that? It turns out it's once we understand render to texture, it's fairly straightforward. So let's take a quick look at it. Let's come back to the PowerPoints. Okay, so the idea is that we're going to do this example by vertex colors, but if you want to really understand this perhaps a little bit better, take the sample code, put in the code from lighting and shading of the cube or texture mapping of the cube, and try it with that. Imagine the problem of trying to pick a face when you've texture mapped some complex image to that where the color is changing all over the place. But the off-screen rendering doesn't care because has each face rendered in a distinct color. And this method is pretty general. This is the one most people will use because the code is fairly simple, and as long as you have a reasonable number of objects, mapping the color back into which object you're pointing to is fairly straightforward. So let's go and look a little bit at the code. So we're assigning a unique color to each object for the off-screen rendering. When I click the mouse, so the loop looks like this, is when I click the mouse, we do the off-screen rendering. I don't need to do lighting for that. If I was using lighting and shading in the normal render, I don't need them here. I don't need to, I need a very simple shaders to do this. Read pixels with 1 pixel corresponding to where the mouse is located is going to give me a color. I map that color back to the whatever, to an identifier for the object, and then I go back to doing my normal rendering until the mouse is clicked again. Okay, so in this example, I just can get away with a single program object because all I'm doing is using colors. There's no texture mapping or anything else. The vertex shader, since in both cases I'm rendering the same cube, the vertex shader is the same as we've been using, and it's the same for both the off-screen and the on-screen rendering. Now the fragment shader is going to store, in this example, all the face colors for picking. So it's going to have those 6 colors built into the fragment shader, and for the normal rendering, it wants to use the color that's coming out of the rasterizer, so that's the color that's interpolated by the rasterizer. And then we're going to send a uniform integer to the fragment shader as an index for what color we're rendering a given faces. So I have the 6 colors for the off-screen rendering. I have the 6 colors built into the shader. I send over an index that says which of those colors I want to use for that face in the off-screen rendering. So let's look at a little code. Here's the fragment shader, the beginning of it. So here's the uniform integer coming across. If it's a normal render, I just render by the varying variable color that's coming out of the rasterizer. But if I've sent over a value of I that's not 0, then I'll render it in one of these 6 colors. So here you have red, green, blue, cyan, magenta, yellow, and unfortunately there is no case statement in GLSL, which is really unfortunate. So you're right, if you're going to use if then else's, which in general is not such a hot idea in shaders. These operations are pretty slow. Generally, if you want to have more efficient code, you'll do something based on the value of I, which will map into these. But this is a little clearer for this example. So if it's 0, I use the fragment color. If it's 1, I use color 1, which is red, 2 green, and so on. So it's a pretty simple fragment shader. But again, this kind of construct is there because I don't have a case statement, but it's pretty inefficient if you're doing a more complex example. Okay, let's look at the setup. We got the shaders now. It's just how we set everything up, and that's pretty much what we've done before. We set up a frame buffer object. We attach a color buffer to it, which is going to be just use a texture for it, and we're going to put that color attachment on. We're going to go back to the normal rendering. So all I've done here is set up a frame buffer object for when I need it. Here's the normal rendering. Okay, now here's an event listener that's waiting for the mouse to happen as soon as a mouse click happens. So when I get a click, I'm going to go, and now the off-screen rendering, so I'm going to bind the frame buffer to that off-screen buffer. I'm going to clear it, and I'm going to do another rendering in which for each I first send over, well, here's the rotation as usual. Then I'm going to send over the index I, so I'm going to get the location of I back from the shader, map it to a value. Then I'm going to draw triangles, 6. I'm going to draw 2 triangles for each of the faces, and I'm going to draw the six faces, 2 triangles per face. Here's the position of the mouse mapped into values that correspond to clip coordinates. Here's the flipping of the Y value, which remember we have to do because Y's in the space of the canvas are flipped from the direction of Y in our WebGL application code. We read a single pixel, get that color, and then again go through some if then else's to look at the values of that color. They're put in the brightest colors. So I simply check if the color of 0 is 255, then it has to be either yellow or magenta or red, and then I look at component 1 and component 2, the green and the blue components if necessary, to decide if it's yellow, magenta, or red. Likewise for the cyan and the green and the blue, and if it's none of those, then I'm pointing at the background, which is gray in this example. So it's pretty straightforward, and you should be able to see if you have a more complex example, or you want to have multiple objects on the display like we had for assignment 2, and you want to say, well, what object am I pointing to now? For example, if I want to move an object, and you take the second assignment and you put a bunch of objects that you've created on there, then simultaneously you can create IDs for each object. Now I could point to a given object, get its ID back, and then do something like drag it across the display to a new position, or do some other operation which changes it. So this is a pretty valuable technique. Here's the event listener. Well, this is the end of it. We go back to after we've rendered that way, we've gotten the position back, we go back to the normal rendering, and we send index 0, which says normal rendering, take the color from the rasterizer, send that out through the fragment shader, and then here's the normal rendering that just renders the 36 triangles that determine that face. So that's the whole example. I hope it's fairly straightforward. One final comment on this is that we also talked about this idea when we talked about interaction of picking by selection and getting a hit list of everything. And it turns out I actually found some code where you really can do this with render to texture. The code is a lot more complex. So what you're doing here is when you click the mouse, you're going to do a render to texture, but what you're going to do in this case is you're going to change the viewing conditions so that the only area that's actually rendered from the scene is an area that corresponds to the area around the mouse. Then you can check what gets rendered to this little area, and that's essentially your hit list. You can keep track of everything that gets rendered to that, or just the last thing, or if you're using a depth buffer, you can just keep track of what's nearest to the viewer, and then map that back into what object or what face you were looking at. But the code is more complex, and this color method works pretty robustly, and I think if you look at applications that use picking, that's what you're almost always going to see.